Determine the sum to infinity of the following series. Let us begin. So here we have a series where the first term is 3, followed by 5 over 4, and 7 over 4 squared, and so on. So this goes on all the way up to infinity. We need to find its sum. Now this particular sum, this is neither an arithmetic series nor a geometric series. It's not an arithmetic series because there is no common difference here, and also not a geometric series because it does not have any common ratio. However, it is composed of an arithmetic sequence and a geometric sequence. That's why it's also referred to as an Arithmetico-Geometric series. So what we can do, we can rewrite this as 3 times 1. So we're going to rewrite each of the terms. So 5 over 4 can be expressed as 5 times 1 over 4, added to 7 times 1 over 4 squared. So here we can make a guess here. So the number in the next term is going to be something of the form 9 multiplied to 1 over 4 cube. Now we have been able to make this prediction because here the terms 3, 5, 7, 9. So these terms are in arithmetic progression. So they're forming an arithmetic sequence. And we have 1 over 4, 1 over 4 squared, and the rest of the terms. These are forming a geometric sequence. That means they are in GP. Now in both of the two cases, they have a fixed common difference and a fixed common ratio. And when we combine the nth term of both of them, that's going to give us the nth term of the series. However, here if we have mentioned here that 1 over 4, 1 over 4 squared, this is the sequence that is in the GP for the following series. So here the common ratio R, that's going to be equals to 1 over 4. We're going to use this fact here. Now to find out the sum, we're going to assume that let S up to infinity, that means summing up to the infinite number of terms, is represented by 3 plus 5 over 4 plus 7 over 4 squared and rest of the terms. Then what we'll do, we'll take the same sum up to the infinity terms, up to infinite number of terms, and multiply it with the common ratio, which is 1 over 4. Now what we'll do, we're going to multiply each terms of the sum as infinity with 1 over 4. So 3 multiplied with 1 over 4, that gives us 3 over 4. Added to 5 over 4 multiplied with 1 over 4, that gives us 5 over 4 squared. Then we have 7 over 4 cube, and this keeps on continuing. Now what we'll do, we'll subtract the quarter of S infinity from S infinity. So we have S up to infinite number of terms minus 1/4 of S up to infinite number of terms. So the first term is going to be 3. Next we have 5 over 4 minus 3 over 4. So that's going to give us 2 over 4. Added to 7 over 4 squared minus 5 over 4 squared. So that's 2 over 4 squared. Added to the next term will be 2 over 4 cubed. This is going to continue. Now we have on the left hand side 3/4 of S infinity. So this is going to be equals to 3 added to. Now if we take the second term and sum it up to all the way up to the infinite number of terms, this is forming a geometric series. So here for this particular series, here the first term, that's 2 over 4, or simply put, this is 1/2, and the common ratio here, so that's going to be, so we take the second term 2 over 4 square and divide it with the first term. So that's going to give us 1 over 4. So this is going to give us the common ratio, and we know the sum up to the infinite number of terms, that's given by 1 over 1 minus the common ratio, a over 1 minus the common ratio. So here a, that's a half, so we have half divided by 1 minus 1/4. So this is going to now give us, so we have 3 over 4 S infinity equals to 3 added to, now half divided by 3/4, so that's going to give us 2/3, which will be 3 over 4 times sum of the infinite terms, that's equals to 11 over 3. So S up to the infinite number of terms, so that's 11 multiplied to 4 divided by we have 3 times 3, so that's going to be 44 over 9. So this is going to be the sum up to infinite terms for the given series, the Arithmetico-Geometric series, 3 plus 5 over 4 plus 7 over 4 squared, and all the way up to infinite number of terms.